Good morning. It's October 16th, 2024, 4:43 a.m. I have to do this in the middle of the night. I'm trying a different latency setting here. See if we can get rid of that terribleness in it. How about some music as well, right? The music was just a touch loud last time, so we'll go a little quieter. First thing I want to show you is this channel right here. Dave Churchill. He is a professor at the University of Newfoundland in Canada. Excellent course. He's going through, I'm watching at the moment, an ECS, Entity Component System. Entity Component Systems drive modern engines. Why? Right? Why does it drive modern engines? Because the problem with inheritance, with making an animal and a dog and a cat, is that what if you want to make something you don't know what it is? You can make a generic one, alien. But what does an alien model look like? Are they all the same? Now you got to differentiate the aliens. So you got these categories where you don't really know what to call it, or you can't define it off. It's something you need to define on the fly, perhaps. The solution to this is an entity system. You abstract away from object-oriented programming and inheritance and polymorphism, and adopt a functional interconnective system. So what it does is you'll have a list of entities, but as the GDC guys will tell you, it's not going to look like this. It's not going to be a vector of entities. In fact, I can show you what that looks like because Almond Core does it. In Almond Core, it looks like this. I do have a vector of entities. However, it's a lot more specialized. It's templated. It is header only. It is functional. I began one of the first iterations of Almond Core attempted to make the job system a component. And I think that might be how it works now, but I was trying to make certain components that shouldn't be components. I have it kind of divided here. You can almost see what should be a component, or the things I was attempting to make a component that maybe shouldn't be. It turns out input, I believe, does need to be a component, but the job system, no. Because when you attach a job system, you basically are creating a new one. Oh, we got a comment. What are you building? I am building, I am teaching C++ from the ground to the most complex, insane, ambitious project you could think of, a game engine. What you don't realize when you start that mission is that it's actually harder than rocket science. Rocket science is easy. Trajectories, If you don't believe me, consider this. There are rockets in games. Imagine making Kerbal Space Program, okay? That was harder. Maybe not harder than NASA's job because there's lives on the line, but bro, can you teach me? I can teach you. We've already covered an entry point which is that basic Hello World program for a C++ program. What I'm looking at right here, not this, well actually both of these. What I'm looking at here, let me make it bigger so you can see. This, look, if you know anything about C++ and you look at this, you'll say, where the hell's the entry point? Well, right now, it's right there, inside of a static library. So, what am I talking about, right? I don't know C++, Adam, so tell me what the hell you're talking about. Sure. If you go in here, where all my code is stored, okay? Okay, we're looking at this one. Okay. So, when I create projects inside of Visual Studio 2022, which is free, by the way. Oh, thanks for the subscription, Eric. I hope you enjoyed the channel. So, where was I? Oh, I forgot what I was talking about there. Okay, so when you're in Visual Studio and you make like a project, you add a new project. Actually, I'll do it and show you what that does. So let's make a console app, a Hello World. This is Hello World is what you call a newbie program for beginners, and the Hello World is the absolute first tutorial. With C++, you're probably, I mean, there's channels on YouTube that, oh, I was looking at one, he does Coding Weekly, he's on episode 358. It's endless. It's a career. It's a lifestyle. And you learn very quickly when you start programming how programming itself and even that specific language becomes your lifestyle or a part of it. It's like a new hobby, but not hobby like mowing the lawn. It's not simple like that. It's more like a hobby like you're a mechanic, but you want to know what it's like to be a carpenter. So you learn about it. That kind of hobby. That deep. Maybe deeper. You're talking about the kind of software that can create software for those jobs. And a lot more. I could make software that could do what AutoCAD does and make it like well, there's house applications where you, construction applications where you build a house architecturally. Not like AutoCAD where it's just like a modeling program for machinery and stuff, finite stuff that needs much more control, but pre-built apps that lay out the walls properly and everything. But you got to think to yourself, what if I want to make a construction game? Now you got to handle power, water. I mean, think about a game like Oxygen Not Included. This stuff is harder than rocket science, but I can teach you how to do it real easily. Look at this. This is the basic Hello World program. We just made a new one here. Let me close these ones down so they don't confuse you. So it's a console application. It just prints Hello World to the console. Look, if I set it as the startup project, let it run. Let's make sure our console's appearing this time. You see what it does? Oh, what the heck? There it goes. Windows took a second to, probably to verify. Well, it actually is probably because my CPU's like totally maxed out. Check this out. Like, you guys want to watch a Charlie Chaplin movie just because we got extra CPU? I mean, this is the wonder. This is the amazing part of society today where you get 6 of these cores, not just one. I mean, there's people out there that got 32 cores. Oh man, I bet you can't find enough to do. Here you go. Just load up every one of these windows, right? All this stuff. This guy's great too, by the way. Clear Value Tax. Everybody should subscribe to him. Unrelated. All right, back to the subject. So, hello world, printing a console. Boom, you're a coder, man. It's that simple. Download 2000 PS 2000. Let me start over. Download Visual Studio. It's Microsoft Visual Studio. It only works on Windows, but you're on Windows because there's like maybe 1% of people who are on Linux. Which is why it's silly to make cross-platform anything anymore. But if I don't, and then Microsoft goes, oh, well, it's $1,000 for Windows now, or something crazy, billion infinite different scenarios where we don't have Windows anymore. Now we don't have our games anymore, even if we built them. So you should always make everything cross-platform. That's just the way it works. Is my video washed out? It's not on here, but it is. Alexa, turn off the computer light.
Okay.
Good enough. All right. So there you go. I just taught you programming. You're now in the world of C++. This is all you need. Just download this program, add a project, get a Hello World going, and then go and start watching my streams. This is the 8th one. You're subscribed today, and you're going to get them all every day. Right about this time of day. I do it overnight because everybody's asleep, so I don't get all the distraction and everything. I make it as simple and as fun as anyone has ever made it. Maybe not as high quality, you know. I'm working with a cell phone, not like studio quality cameras. But I'm also not charging you any money, so. And if you gotta watch ads, you can take that up with YouTube. It's got nothing to do with me. Not yet. Once you get a console application, you're gonna go, oh well, how does a program look like, right? Let's go look at some. See that? There's a DLL. There's a DLL. There's a log file. What's in the dump stack.log? Well, I probably shouldn't show you guys that actually. I might have personal information, but we can go and look at we need to find something simple because we don't want to be confused by what we're looking at. Let me see what I can dig up here. Well, let's go look at a game in Steam. Let's go look at, I have some really, Steam apps? Yeah, common. This is what I got installed. Out of these, what's the simplest game? Probably Space Trash Scavenger. It's a Unity game. So, if you know anything about Unity modding, actually, no, we can use this. All right, look, see, they got the executable there. When you're making your console app, it's going to create an executable right there. That's the one we moved to show that it was standalone. But it's going to create this, and we created a static lib. We'll talk about that in a second. The executable, and the reason you can't see this right here is because you don't have file name extensions and hidden items. Windows hides it from you. They're trying to keep you sheeple. There's a word you ain't heard in a minute. So, you get this executable. It's accompanied by things like DLLs and libs, static libraries, and they're additional code. It's like a separate piece. You could think of it like, oh, what's something simple that, Anytime I try to think of something simple, and HTML and stuff pops into my head. So, that's a little bit hard to describe to someone that's very fresh to computers. I mean, I can relate it to something in the real world. It's like a person in their briefcase. There's a lot going on in your head, but the The stuff that you store in your briefcase is stuff you just can't remember. It's kind of like that, except you'll get very familiar with your code. And the best advice I can give to a new coder is go slow. And I don't mean in learning. That's the opposite. You want to learn fast, code slow. Unlike most other things in life. One advantage you have in the digital world is that if you're careful to a degree, you can get pretty sloppy. And you can just do things and delete it and start over and just learn. And right now, if you were to take this stuff, can be so valuable if you actually want to do anything with it or make anything with it, which is fairly easy, fairly within your grasp for pretty much anybody. You know, you could trash your whole computer working on this, and it's probably still worth it to you just for the education. Pick up a C++ book from the library. Go there and read one. Just browse through it. You'll learn more than you can imagine. Start with easier types of code, not C++. Go try Rust. It's the fastest in the world. It's Microsoft only. Super simple program, super simple syntax. You could try beginner languages. Some of them are very powerful. You could even try visual programming. That's where you go and you find a website that does visual programming, and it basically makes little modules, and you take and you drag and drop them into place, and it's kind of like playing Factorio to a degree. And if you're really, really lazy, go play Factorio. That's functional programming. It's procedural. One thing precedes the next. One foot in front of the other. The stuff is simple, but complex. The complex part is we're talking about certain things, like templates, object-oriented, complex class setups. It's got its complex, but you could easily start writing an RP if running. Set that to false. You could even take command line arguments and tell it if it should run. You could start it running, and then you could have a condition if, I don't know, just pseudocode here. This is called rubber ducking. When I bounce it off other people and when I do certain things. If quit button dot press. This is just fake code at the moment, but it does look similar to that when you get it. If quit button is pressed, then if it's pressed and that's true, then you'd set running to equal false, and that would shut down your program. I wonder if I have. Let's take a look at our input system real quick. Maybe we can make this work real quick. If it's pressed, gotta get the key code. Where's the key code? We have one, or it just checks if it is. Like, are you a key? Okay, you're pressed. That kind of stuff is possible sometimes. You see how complex this is. There's a lot of files. This is all header only, so you're looking at half the files you'd normally look at, but the whole implementation is still there. I could literally take this stuff right here into engine CPP. This stuff is not that difficult. Anybody can do it. What are the different application areas of C++? C++ is the most capable language in the world. because it's the highest level language that has full capability. Now, saying that, there have been languages developed after that. The only one that's cross-platform is Go. Go was created by Google. That's why it's called Go. And Google created it because they hate C++. So if you want something that's a little more cut, a little easier to do, cross-platform and modern, try the Go language. And then come back and learn C++ and realize what you're missing out on. The problem with abstracted languages such as Go is that they're a major hitch, because surprise, surprise, Go is written in C++. And so is most other languages. It's low level. It's a medium level language, okay? What does that mean? Well, you've got binary. That's what the computer's churning over. It's churning over binary, but that communicates, that's created because humans don't read and write binary unless they're creating a kernel. But you create a kernel so that you can create a layer of machine code. We call it assembly. Assembly language is the machine code we use. That's used on every system. No one's ever created a different assembly language that's been popular. Assembly language was probably the one that won out in the past. Anyway, you've got an actual codable level, the machine level. That's where you start coding in things like C++. A higher level, a little bit higher. It's low level in terms of human writable code, what people code in every day. So in regards to that, C++ is practically the lowest level. I'm not sure if Python's written in it. Python might also be... Uh-oh, I'm getting an error. YouTube's having an issue. Hang on. It says that it's not getting... It says it's not getting enough video to keep up. Oh. You know, this whole thing is probably just because I'm on Wi-Fi now. And I don't have that optimally set up. But anyway, hopefully it's not cutting me out too badly. But binary, assembly, C++, languages like Python and BASIC and a bunch of others. C was invented to replace B. C++ was invented to replace C. Go was invented to replace C++. You can go with the hitching language if you like. They'll smooth it out eventually. But that might be another iteration of computers before we get there. They've smoothed it out to a degree where you can't tell that Unity games suck. My opinion. Just my opinion. It's also fact, but it's my opinion. This is why you should learn C++. This is why, if you want to make a game, make it your damn self. Because then you don't have to debug someone else's code. And you don't have to use a game that's written in a language that hitches like hell. And if you like Twitch-style games, aka first-person shooters, instant-style games, games that require absolute speed, then you're only going to make that with C++. Siege is written in C++. Every Ubisoft game is written in C++. All the greatest games are written, hard-coded, C++. If they have an engine, it's specific to that game. Engines are a part of games. You don't need one, but you need one. If you catch my drift. Try making a game without one. It's not as much fun. It's not as easy because you don't have that abstracted layer that says, you know, give me this part. I just need to deal with rendering. Give me rendering, and then you can do stuff with rendering, and then send it back. As opposed to making your own game, the rendering is part of it. So you're constantly trying to rearrange it and find a way for that to work until you finally find a framework for the concept of your design. And it's very specifically tailored, and to me, that's harder. It might be less code, but it seems like overall that would be a harder task. unless the game were very small and had very few moving parts, then it would be ideal. But if you're trying to call into rendering from functional programming that's in the same file, that's a headache. Because you got to understand how this works. If I wanted to just do like let me teach you what procedural programming is. This is how I learned how to code. So instead of having like classes I can call render and, you know, instead of having something like that, I would have done it something like, whoops, I didn't do that. I just did that. All I did was double tab after hitting F, if, like this. I typed if, double tab. That is cool. Learn something new every day. What you doing? I'm coding C++. Learn along with me. If true, no, not if true. If, I guess we'd have to have something to represent the player. So let's try, and back then I didn't even understand strings. So I would just do like integer player. I would have initialized it as 0, or maybe I'd say player equals 1 because there's just one player. So then I'd say if player was probably, I'd say something like greater than or equal to 0, then we do something with player. Because in my program, I knew I wasn't creating 2 players. I was just creating the 1. So I could do things like this. And this was just how I learned. But I could say like player, and of course it's just an integer, so you could plus it. You could minus it. That's about all you could do. So then I would get a little deeper and I would do some function where I'd have, I always worked with voids because I didn't even understand integers in functions. But the way integers and functions work is that you create an integer function and that gives it a value. That gives it a type. And because it has a type, it has a return type. So it returns an integer. And then you might have something like integer a, and then you want it to return a because you feed something into the function, and then you get something back out of it. So then if you used function, you'd have, let's say we just want to shove player in there, and we already know player equals 1. So if we just shove it in, it's just going to give us that back. So if we go std count to print it out so we can see something, this is a little bit harder to type, but man, is it cleaner. Especially when you have some text there. So that just creates a new line. This just prints player, which is an integer, so it's not going to like that. It's not going to print it right. Why isn't this working? We already have IOStream. Why isn't this working? What? Huh. I missed something somewhere. Oh, it's the function. Right there. Let's get rid of the while loop for now. So this is how I started programming. See that? Hello world 1. So what it's doing is printing this, and then it's evaluating this. I guess you could almost call that an algorithm. It's saying if player is greater or equal to 0, so as long as the player is, I guess, alive, if he exists, if this integer equals 1, then we're going to fire this function and this function. When it goes through here, it spits it back out. Let me try something. Now we already learned that this is a reference. So if we want to pass this into the function, we need to make that a reference pointer so that it gets the reference. It's going to basically take player and assign player to A. Now why does it have to do that? Well, because we didn't do this. Because if you wanted to assign A, you got to give it the value it expects to assign. If you give it a player integer, it's not a value, it's a I don't know, the name escapes me. I don't know what to call that. It is a label. It is I think a label is what they call it. But it is a identifier. An identifier. Which works very similar to a class. Why? Well, because this is also an identifier. You see? Why ain't that working? So now we have a player class. Now this is the object-oriented way. Okay? But you can have what's called a hybrid approach as well. It's hard to navigate this sometimes. Okay. If you want a hybrid approach, you could say, I don't know, why don't we just make that that? Now we're using functional and a little bit of OOP, or classes anyway. But we wanted to do something with it. We want to increment A, okay? So now, what we should get, see now I can't see this because it's inside the player. Okay, it's just a value, so the way that works is well, let's just get rid of that for this moment, because I want to show you something else first. I don't want to have to rewrite that whole thing yet. But that's how programming works. It's a little bit trial and error. Now you see that's a 2, okay? Because it's going through our function. So we send player through the function, and then we print it out. So it's getting incremented. We're transforming player right here, which technically should be there for readability. We're transforming player to A. Then we're incrementing A and returning it, which returns player, incremented. That's how that works. And now you can see how you can at least do an integer with if statements and affect it, change things. Like, let's say it's not player, let's say it's health. And let's say it starts at 100. And let's say it's inside this player class. And let's say that it doesn't start at 100. And that it's private. And we have a public constructor that initializes, well, we'll just do the one. We'll call it H because it's health. We'll set up a member initializer or whatever, the constructor, and set our private variable that can't be accessed by player. I'll show you how that works. How does this work? Like this? No. Like this. Okay. What am I doing wrong here? This? Let me take a look at some other code for a second so I can refresh my memory here. So we don't take all day trying to figure this out. And see, these are inline functions. That's a whole different thing. It's an optimization. Because, okay, yeah, it does require that. What did I miss there? They're probably the semicolon at the end. Okay, so now player is inaccessible, but it's not player anymore. That doesn't exist. So if player, the class, and I think we might have to, that's not how we do that. The way we do that, we're going to give them 100% health, right? Or 100 health. Not, I mean, you could call that percent, but it's 100 health. Now, if the player doesn't, this is a not. When you use a exclamation point in C++, that's a not symbol. So if I say if P not equal, are we going to do null pointer, or are we going to do it's kind of difficult to do with this because we'd have to set it up as a pointer for this condition to be proper. Let's try. Condition for it to lose health. We'll call this damage, and we'll actually minus, and we'll stick that inside the class. That's we don't need an integer, we can just do a void on damage. And because there's implementation here, this would normally need to be in a CPP file, a .cpp, but we can just declare it outside the class. And then we take this as a declaration inside the class, like so. Now this can't return because it's not an integer, so we'll go back to integer. Okay, and that's why you have an integer on your function and an integer inside its initializer. I'm not sure that's the proper term, but anyway, that's how that works. So function becomes on damage, and that actually damages the player, you see, because it goes and it decrements the health. Instead of player, player's now health. So it decrements here anything we stick in on damage. Anything that goes here is going to get decremented. So what we want is not player, not the class player, but inside the class player, you see it has a function for on damage. But what we want is to get our hands on this value. Actually, what we want is this value. This just simply sets that value because it's private. We can't access it, okay? That's what private means. Now, like, for example, what if I made that not private? It's in public. Now, I can access it. See that? That's what encapsulation is, okay? It hides the implementation, and it prevents you from doing anything with it. It's private. Only the class itself can affect that. access it? Well, the way you access it, and the reason why you access it like this, is so that it can't be changed. Like, let's say I want it static, and it's just permanent. It doesn't change. Whatever it's set to, it's set to. But there's not going to be more than one of these, is what that means. In fact, if you made two players like this, player 2. Okay, we can make another player. Now, if you make another player, they're going to share the same health. That's what static does. If you make that constant, now you can't change it without being mutable. Let's just go with regular for now, because every time we want it to have its own private health. And that's a good reason to make it private, because you don't want to make it static and have it shared, and you don't want to make it constant and have it be mutable. Well, you probably do, but in the short term, learning how, you want this as simple as possible. You can pick up those concepts later. And even if you were to write an engine, you can go back through it and layer it with more. It's not that difficult. It's designed to do it that way. So how do we get the health? What we get, the way we get it, is with something very common to object-oriented programming. It's called getters and setters. So what we do is we say void get health, and we create a new function. And this function's job, we can even create it in the instantiation of it. We can say return health, because this class, it's within the class, so this function has access to it. There we go. And usually you can set it up just like this to it doesn't match the return type. See, it's locked. See that? And it says return value does not match the function type because I made it void. So if I make it an integer, get health makes sense. It also is a little bit descriptive of what get health gives you, or what health itself is. Let's see. You might be able to do this now. Yes. Okay. So now you can access it with get health. So what that's going to do, okay, it says initial value of reference to non-const must be an L value. We'll get to that in a minute. This would end up being that as well. In fact, let's just build that real quick. I just want to show you what that looks like. Just so you can see that it actually will reach in here and get this otherwise impossible to touch value right there. So we know it works, but we got a problem with our class instantiation here. We also got a problem with our conditional statement. Null just equals 0. So all we really need to do is make p. Now, I've got to warn you, I don't even think you need to make p for that to say if p and still fire or not fire, one of the two. Another thing is we might not need that at all. Okay, so the way we're going to do this is whichever way it's going to allow us, I guess. One way you can do this See, this stuff can be difficult, even for someone that knows how to do it. But honestly, I just need to refresh. I actually took a long break from coding. And I forgot pretty much everything. Let's try it like this. We'll make it as a pointer. Why is that a problem? The value of type in cannot be used to initialize an entity of type player pointer. We do this then. Okay, I got another idea. Let's make our setter. There we go. Okay, so do we want it to return health? What do we want it to do here? This one's going to return health, but this one isn't returning health. This one is going to, this one's going to be a void, because we don't need a return. What we want is health to equal 100. Or actually, we want to set it to whatever we have, right? So we need, we'll just use X there. So integer X, and remember, we want a reference if we're using an identifier. This time we're not, though. This time we're going to pass it the actual value, and so therefore health equals X, and that's it. We don't need to return it because it's internal. So then we can just get it. So if we go on damage, okay, so what we need to do is we got our player, and we no longer, even though that's how you create a player, we no longer do that. We don't want to create it as a null pointer, but we could create no default constructor. So you'd have to create it like that. But if you do that, you have to do this. And that's how that works. What's going on here? Type name is not allowed. Oh, my bad. The one you created. Because this is what you're creating. It equals a new. So even though you're using it here, it's being assigned to P. So then you have to delete P. So now that we have a pointer, now we should be able to do, oh, right. This is not for pointers. This is for pointers. And then we're going to get the health. On damage. On damage. Yeah, we need to get the health for on damage. So it can be passed in. That's going to return A, so that's not what we want. If that's just returning, what we could do is we could not take an argument. That's one thing we could do. Or we could pass it, let's see what we're doing here. We're passing it a pointer, not that. We're passing it a pointer. I'm just trying to sort out the pointer here. L value. You basically want, oops. You basically want to set this to something like enter. You could still use X, but it gets confusing when you start using the same one over and over and over. In functions and stuff, you should just have one that you use, X, whatever. You know, try to make ones that are in classes like descriptive, like the H. And then here you can just ABCD. So you'd have some in functions and you'd have some in here. Those will always remain separate. The ones in classes will always remain separate, but you want it descriptive so that at a glance you can tell which one it is. So now we have X equals the health. We're going to pass that in, but then because we did it that way, we also have to call back into the class and set the health manually with X. So one way you can actually kind of improve this, maybe improve it. It could cause bugs that are harder to discern, etc. But one way you can fix that up, make it a little more optimal to at least read, is like so. And then this one could just go ahead and print X because it's equal to what the health is actually set to, because you're setting it right here. So you're setting the health to X and then you're printing it out at that same thing. And that's a huge optimization. This is how you always want to do it, because rather than go and get this all over again, right? Makes sense. I don't speak that language. English, please. Okay, so this should all work now. And it should reduce the health by 1. So what it should do is print hello world and 99. Do we know programming yet? This is only like the 3rd time I've shown you in these 8 streams. But that's how you do functional combined with class-based or OOP. Basically, the hybrid approach would be to handle small things in OOP that handle abstraction well. And the first thing you're going to think is, oh, animal, player. I want player enemy. I want to start with my base class of character, and I'm going to have player and enemy. No. The reason why, ECS, Entity Component System. It handles all the entities. Doesn't matter if they're a player, an item in your game. It's an entity. That's why it's genericized to entity, because it's everything. If it's an object, if it's a game and it's a physical object like a rock, it's an entity. Now, a rock needs a whole lot different components than a player. Player's got to have camera component. They all have to have rendering. Rocks don't necessarily need physics. If you had a bird in your game, it doesn't need physics. What's it need physics for? It flies around. Unless it's physics-based flying, you don't need it. So you can detach those components and fake it with really small implementations. Like, for example, that. Okay? And then, like, I don't know, this would be in the component system, but attach a component. Now, you're making Microsoft Flight Simulator, but you're putting in, well, not Microsoft, sorry, I don't mean to use their trademark. let's say you're making a flight simulator. They make the best. So, man, have you seen the new one? Holy moly. So, you might attach a physics component to your plane, but because the bird is like you just fly through it or something, if you actually did hit it, it's just a small bird for like a particle effect almost. So you might attach a component, physics, to your plane, but for your little particle bird, you don't want the physics, so you don't attach that component to the entity. And the reason you do that is so that you can have basically any on-the-fly type of entity. So if you want to just suddenly create those birds out of the blue, and you're like, oh, I don't need the physics for these. It's a good thing I didn't inherit a whole physics engine into this inherited massive overhead class system with polymorphism, right? Right. And you start to see where the savings is, and then you can start to affect each component individually, and it modularizes the code entirely. And that's what OOP doesn't do, and that's why it sucks. But it's got its uses, like everything else, and removed from the language. So, how do you use it? Well, the way it's ended up using in the entry point line. So basically, the way everybody's going to use it is, and you could have different variations, of course, but you see I have class engine. The element engine is nothing more than an inclusion, like almost every library has. The implementation separate and clean, so that when you come into the engine, you can have it named if you want, like this. Looks nice and pretty. It's my engine, right? Include almond engine, what's supposed to be almond core. So what is almond engine.h? Well, almond engine.h just includes entry point, because you don't want entry point.h at the top of your program. That would look stupid, right? It would look stupid. It's not as cool as almond engine, and it's not branded, and trademarks are a thing. So that's why that. As far as engine, how is it object-oriented? How is it polymorphic? It's not. But it is a class. And then each... well, here's a good example. The rendering context. So renderer is one of those inheriting systems, because it's a complex system that's pretty finite. It's a very black box system to begin with. Yeah, there's all a bunch of parts you need to interact with, but renderer or renderer.h in your engine is essentially a base class to inherit your context classes or driver implementations, your backends, your contexts, your cross-platform implementations, your individual implementations. There's 1,000 words for these things. Now, that being said, where were we? Oops. So that's why you don't do this. Don't. No polymorphism, no inheritance, no OOP on your entities. None of that shit. We honestly need to rip this out of every C++ tutorial ever created. Do not ever make a C++ tutorial that uses animal as an OOP example. Instead, use renderer. Remember that. Because that would be a world example. And you can absolutely fake anything. Can you read that? Fake everything. Fake everything you can. Okay? It's all smoke and mirrors anyway. So your job as a game designer is to be a fucking magician. Okay? Excuse the language, but I think it's appropriate. It's all smoke and mirrors. It's all fake. It's all binary. Why wouldn't you do it the way the binary likes it? That's what you're doing, and that shows you as a software developer or designer. Designers tend to be the ones that'll bloat your code. Developers are the programmers that have to work magic for designers. So they're two separate jobs, and they have to be looked at differently. So when you're talking these kinds of things, mostly the developer is in control of the design of game engines. But in the industry, in software development, oftentimes you have a UX. You don't talk about UX in game development because it's user experience. And a user experience is different than a user interface. User interface is buttons, switches, etc. User experience is how you mix that together in the face of a program, along with images and other things, to create a context which is known as UX, the user experience. And it literally extends to your end user results, and you test it. It's a design thing. Programmers always call it GUI. Designers call it UX. And that is why the modern phrase is UX UI. Because take it how you like it. So, what else can I teach you? I mean, this pretty much sums it up. But I don't want you to go and start coding like this. This is functional. This is object-oriented. Don't ever make a player class. Don't ever instantiate, or don't ever inherit your, make an entity component system. That's the modern way. Let's see. Let's take a look at like other parts of a modern game engine. That'll be fun. Okay, so the job system, what is that? That's threading. You got multi-threading, takes the form of a job system, a queue, and thread pooling. This is let me think of a good term to describe it. First of all, thread pooling is limiting your threads. That's all it is. It's setting a finite amount of threads and pooling it and just reusing threads as they become available. And the reason you do that is because you don't want to overwhelm your system with threads. And my experimentation shows that if you have more than twice as many threads as cores, it goes downhill from there. And a lot of these engines out there are using 1,024 threads. So what you've done is just killed half of your extra multi-threading. It used to be a good idea to do that. There's something called Phi where you micro-thread it. You can't do that anymore. That doesn't work. What you want to do is use the number of cores you have, period. Here's the plan that I've come up with. Along with the job system, worker threads, task system, task scheduler, etc., 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 you want to thread your engine with coroutines, because the coroutines will allow your major systems to communicate with each other directly, and they have a pause and wait system, and then those threads will spawn off worker threads with the job system, and that'll spool and do all the hard work while these main threads are locked in doing their job. And what you do is you have I looked up the Steam stats. Nobody's got less than a 6 core. Don't program for them. Let the overhead kill their system. So you'll have 6 threads. Rendering, AI, physics. The rendering is on the main thread. It also handles input. So you've got main thread, rendering, input, and graphical user interface. Next thread is your physics or AI, both. So that's 3 threads. Now, you don't really technically need any more than that. But you can run everything else on a 4th thread. Meaning all everything you're going to do in the engine layer, the logging, the scene handling, the event manager, the entry point system, everything. Even call that the main thread and run rendering on a separate thread. You're going to do coroutines so they can communicate easily with whatever. Who cares? Because when you need the physics system to talk to the rendering, everything's waiting on it anyway. So do that, have it communicate. That's the fastest way you can do it. So then with your remaining threads, you run the job system. So you've got, how many are we up to? 4 or 5? We're up to about 5 threads, okay? You've still got 1 remaining. Fine. Leave it alone. Let it run the job system. Let it be that 1 thread that powers through everything. So then you got your job system running on thread number 4. Yeah, it'd be running on, what did I say? We got main thread, and then we got render thread, physics and AI thread. Job thread will be thread number 5. Thread number 6 is your first thread in your thread pool, okay? Thread pool should be exactly the same as coroutines. It's going to be STD hardware concurrency. So you're going to take your other 6 threads. Remember, I told you you could have 2 per core? Yeah, so you're going to get one dedicated thread left from your original cores. Then you're going to get 6 more additional worker threads that are going to run on all of these. You need a wait-free queue. Forget the lock-free queue. Forget the spin lock. The fastest, most robust, and scalable way is a wait-free queue. It's on my GitHub. Go get it. So that's how you make a multi-threaded modern gaming engine using coroutines combined with threading, absolutely no micro-threading, and absolutely no more threads than twice as many cores. That's it. That's all you need to know about multi-threading. And GPT can write the crap for you. So, well, there's not a whole lot left to talk about. We talked about the entity component system. Mine happens to be quite elaborate, and we'll go into that later. Because my engine is, there's a secret about it I'm hiding. It's nothing that hasn't been done before, but I plan on being the first engine to do it and make it widely available. And I'm going to make a whole bunch of examples of how games over the years have used this special feature. And I'm not giving anything away yet. But, watch my channel. Pay attention. Maybe you'll have an idea. So, the way that I've chosen to do my saving is through events. I actually save based on events. Because this is made not just for a game engine, but for an entry point. See this part right here, the rendering, this is just something I'm working on. This is part of Almond Core. There is no rendering in Almond Core. It renders to console, if anything. And the idea is for it to be a software suite where you can build any software off of it. And even though it's got an entity component system, that actually can be used in a lot of software. You might have to twist your way of thinking a little bit, but it can be used. And you're going to find in the future this is done more often, I think. Genericizing the engine. Another thing I want to get into real soon. This is something I had for another version of Almond Core. It was going to be called Almond Shell. Unfortunately, the way that I'm going to be doing graphical user interface does not align with the way that I wanted to do Almond Shell. But I think I might do Almond Shell as the plugin version anyway. And then we're talking about a black box system. I want to create a central, it's basically a Java JRE. And then you guys can make plugins and not have to write any of this crap. You're just writing plugins, and it's your whole program, like calculator plugin. And then I want it to have like a nice interface. Uh-oh, it's that time of day, guys. We got to get out of here, or else we're gonna get nailed with a bunch of noise. But we'll wrap this up real quick. So I wanted to do graphical user interface in 2D and then overlay that on 3D, but I don't think that's going to work. So instead, we'll just do Almond Shell as the plugin system. It'll be like a black box runtime, and just start making plugins. And eventually, I mean, how many apps do you even have on your computer right now? Me? Not a lot. Most of the software I use is really big software, like a modeling program, a rendering engine, games, paint programs. Guys, I'm building a rendering engine. We can have all of that. We could just put it all in one program and not deal with this crap anymore. What are you doing? Little tiny apps on your phone? Dude, I'm going to show you how we can make an entire, and we're going to put every app into one app on your phone. And then we won't need any of this crap anymore. Nobody will ever have to pay for software again. They'll just write plugins for Almond Engine. That's it. Let's close on that. This is good enough. It's almost 6 a.m. and it's time for the kids to get on the bus. So we're going to get out of here before we have to listen to any of that. It has been an adventure, as always, folks. Welcome to anybody who's new. Subscribe for updates if that's what you want to do. And feel free to like, comment, any of that. It all helps the channel. Anything that helps the channel helps me to bring this free material for you guys. We're building games and game engines for free and giving it away for free. It's licensed under the Apache 2.0. My GitHub is under my YouTube now. And it's also got a name, Autodidact, not with the T on the end. It's just a username. So if you want all this free code, and there's a bunch of free code already there, help yourself and help me help you. And mine Rushford, it's been real. Happy coding.